Hello, class. This will be the recorded lecture for continuing in section 7.1. And we're going to talk about calculations using tables. This is how I used to have to do it before all this fancy technology. And it's a good, I think it's a good way to start before we jump into the fancy technology to explain to you how these calculations work in the sense of using z-scores to normalize the normal distribution and be able to use the tables to calculate certain probabilities, which will be corresponding to areas underneath the curve. And so I have uploaded to our Canvas account tables that I will be using. And the book also has tables as well, and they're exactly the same tables. It's just easier for me to reference a PDF file that I have on my computer. So feel free to use any table that you feel comfortable with. So getting started, let me pull up the presentations that we have. You'll be sick by the time we're done with this class seeing this kind of normal distribution curve. But this is this idea of the probability density. Remember now, when we talk about a normal distribution, we're talking about continuous variables. So the idea of some calculations you'll see compared to the binomial is going to be a little bit different. And so first concept, and this is important, is the idea that in a normal distribution, that peak value where the mean, the median, and the mode are all the same number. And remember, at the mean, the z-score is 0, right? That's how we normalize it. And as the standard deviation gets small, you'll see that the peak rises. There's more points close to the mean. And as the standard deviation gets smaller, or larger, excuse me, there'll be a more spread, and you'll find that there are less points close to the mean. And so the curve gets flatter. So that just depends on the data, of course. And as I alluded to, here is the real empirical rule, where you could see that when you get to a z-score of 3 or -3, between those two is 99.7%. If you remember, the book introduced this crazy idea of almost all back in chapter 3, which I thought was kind of ridiculous. But anyways, here is the actual numbers: 68 between a z-score of plus or minus 1, 95 between a z-score of plus or minus 2, and 99.7% of a z-score of plus or minus 3. So how do we use these z-scores and calculate some probabilities with these areas underneath the curve? So let me just walk through this. So again, as we discussed, this normalization using z-scores. And so remember, we have this mu of 0, that's be a z-score of 0. And the z-score of, if you go to the right, one standard deviation, it's +1. If you go to the left, it's -1. And so here's the definition that when we read the z-scores, again, from the tables, you'll be calculating the area from that z-score all the way to the left, so down to 0. So that it is this area here in blue underneath the curve. A better graph or a better illustration would be something like this. So it's all the area to the left. So it's from the z-score lower. So there's a couple numbers that you should know right away, right? If the z-score is 0, you have 50% below the mean, and then that implies that you would have 50% above the mean as well. And you could see here on this table, the z-score of 0 implies 0.5, which is 50%, right? So half the points are below the mean and half the points are above the mean. So the value of the area that you read off the z-score table, and same with technology, it's always less than. So it'll always be to the left. So let's take a look at this. So say like you have a z-score of 1.26. So if you take a look at the table, and here's an example of the table that I've uploaded, you would go down to 1.6, which is right here. And then you go over to 0.6 up here, and that would give you 1.2 is right here. And then you go over to 0.6, and you would read that number of 0.8962. And so you would see here, you get that same number that you would get right out of the table that the book has as well. And so what does that mean? Well, let me show you here real quick. So what that means here is that if you have this normal distribution curve and you have, that's not a pretty one, but say like the z-score here of 1.26. So the area all the way down here is 0.8962. So what does that mean is that if you had the probability of a z-score of less than 1.26, that would be 0.8962. So that's what we mean by that calculation. So if you had, say, 1,000 points, and you wanted to know, well, how many points are below that, you would multiply it by that probability, and you would get 896.2 points would be below that. And what the beauty of this is that if you go above, and that's why it's important to think about it, you take the table and you subtract it from 1. So the probability of z being greater than 1.26 is 1 minus the probability of z being less than 1.26. So basically you get out your calculator and subtract, because remember, it's super important to understand that the total area underneath the curve is always 1. And so if you hit equal sign there, let me do it quick here, 8962 minus, and so that's a little over 10%, 1038. So how many points are above the mean if you had 1,000? Well, you multiply the percentage times the number of points, and it would be 103.8. And if you add these two together, you better get back to your 1,000 points, right? So that's the concept, and we're going to be using this concept throughout. And here's the big difference, again, with the difference between and again, we take the z value of 1.26. So here's the difference between discrete and continuous. Because it's continuous, right? We don't have to do like a step, right? In the sense that when we have a discrete, we have a number 1. What's greater than 1? Well, the next step is 2. Here, because it's continuous, it's that little movement to the left or right, which is virtually the same number. So when we talk about less than and greater than, we talk about z less than 1.26, and the opposite of that is 1 minus x is greater than 1.26. So you don't have to worry about that jump. The other thing that's really important is that in a continuous distribution, the probability of any single point, and we'll just call it z equals 1.26, is always 0. You can't just take the area underneath a curve of a continuous curve of a single point. And so if any of you have taken calculus before, we're talking about the area, and we use this idea of integral. and say like you went from the same point, whoops. If you take the integral of that function, when you use these same points, it always ends up being 0. So for those of you that didn't take calculus, don't worry about that. Just hopefully you'll trust me in the sense that the area of a single point underneath a continuous distribution is always 0. You can't take the area of a curve of a single point unless it's discrete. And so here we're never going to do the equal aspects of it. Okay. So now if we do this idea of the area above, as I pointed out before, what you want to do is you take the area that you get in the table and you always subtract it from 1. And so again, looking at this table, minus 0.58. So here, this is the first decimal and across is the second decimal. And you read that value, you get 0.2810. And so you could see below that would be 0.2810. If you go above that, it would be 1 minus that. And if you did that calculation, you would get 0.719. So what do we do if we're in between 2 points? Well, that's kind of interesting. And so the idea is you take the big one and then you subtract it from the small one. And so that's what we have an example here. But it's kind of nice to kind of show you this on the whiteboard. And so let me see if I could draw a little bit better. Yeah, that one's a little better, right? So say like I took a z-score here of this red one, and I'm going to change that to blue now. Say like the z-score is 1. And so when you read the table, you're going to get everything, right? All this down here. Let's see. Whoa. That did not go as planned. Try to put the distribution back up here. There we go. So if you calculate that area of 1, so that would be P of Z equals 1, and you would get that area. And if you took a look at the table for 1, that would be 0.8413. And then if we take a look, let's do a different color. Let's do orange. It's hard to see orange. Let's do green. There we go. One more time. There we go. And so if we do green in this case, and we do Z equals -1. And remember, between these two, we know it's 68% from that empirical rule, right? So, but if we read off the table, what ends up happening is you get this part here, right? And you can see that there's an overlap. And so what you want to do is you want to subtract the overlap. That's what I was trying to get at. And so the idea is that if you read P of Z equals -1 from the chart, and I'll just look at it real quick here, that would be 0.1587. And so if you subtract these two, and you did that calculation, you should get your 68%. So let me do that, 8413, and then 1587 minus, and you see you get 68.26. So when you do these calculations, let me pull the slide back up. You take the area below 0.42 and then you take the area below the z-score of minus 1.45 and you subtract the 2. And you can see that when we do that subtraction, it looks like, let's see on the next slide here, you do the subtraction, you end up with what's left, which would be 0.5893. So let me do one, because it seems like I think it's good to do one example. And so let's say I asked you, what is the probability of, say, the z-score between 2 and minus 1. So if you look at that little it's usually easier to do that. There we go. And so this would be a z-score of 0. That would be our mean. So if we go up to 2, it'd be somewhere up here. If we go down to minus 1, it would be here. Whoops. So what we're trying to calculate, let me put that in red, is this area here. And so that would be the probability of z being less than 2 minus the probability of z being less than minus 1. So if you go to the charts, I'll pull up the charts and share that and show you how to do this calculation if you want to use the tables. And all the homework, and at least in this section, if you want to use the tables, you're welcome to. So you could see that z of minus 1 is 0.1587. You see that right there, hopefully. And so if we go back to the whiteboard, let me put those numbers in there. And so if we go to the whiteboard, that would be 0.1587. And so we want to subtract that from z is less than 2. So we have to go all the way down to the 2. And there's 2.0.9772. So if we go back to the whiteboard, and sorry about that, 0.9972, and you get out your calculator and you do this calculation, you would see you get 0.9978, enter, and then 0.1587 minus, and you would see that the area would be 0.8391. And you can see that these z-score tables give you 4 decimal points. So when you do these calculations, you usually leave them as a 4 decimal point calculation. So that ends the recorded lecture for z-scores, areas, and probabilities using tables. The next one is I'm going to show you how to use the spreadsheet to do all these calculations. The book has a very good explanation on how to use your fancy calculator as well. So I would recommend getting good at one of those and using that for the homework because it's a little bit easier. So for lots of better word, pick your poison and get good at using one or the other. I'm going to share the spreadsheet in the next recorded lecture.